In this video, I'm going to go over the solutions to numbers 2 and 4 from our Dropbox Quiz 1. In number 2, we have a ship that leaves port at noon and heads due west at 20 knots, which is just 20 nautical miles per hour. At 2 o'clock, the ship changes course to a bearing of north 54 degrees west. I'm going to start with my diagram. Here's port, and our ship travels due west for 2 hours, because we go from noon to 2 o'clock before they change direction. And 2 hours at 20 miles per hour gives us a distance of 40 miles. Then we're changing to a specific bearing. When they give us a bearing like this, we need to start with a due north line, because they told us to start with north. And then we want to rotate 54 degrees to the west side, which would be the left side. We want to find the ship's bearing and distance from port of departure at 3 p.m. So that's an additional hour that's passed. And they've maintained this 20 miles per hour speed. So we have a distance of 20 miles on this side. And what we're asked to find is this distance here from port and what the bearing is from port at that time. Well, so here we have a triangle, but the problem with this triangle is that we don't have a right triangle. See, this due north line intercepts this due west line at a 90-degree angle. So we have an angle of 144 there, and right now we only know how to solve right angle trig. That's the only time SOHCAHTOA applies. So we're going to have to make some additions to our diagram. I'm going to do two things. First, I'm going to extend my due west line. And then I'm going to drop a perpendicular from our location at 3 o'clock. Now I'm dropping a perpendicular to this due west line. This is going to create a 90-degree angle. That due west line that I extended on the bottom, intercepted with this red due north line, creates a 90-degree angle here. And we know that a portion of that 90-degree angle is 54 degrees, so we can just find its complement to find the angle inside this triangle. And that'll be 36 degrees. Our plan is, I'm going to break out this little right triangle here that we've created. And I'm going to find the bottom side. I'll call it A. And I'll find the left side, I'll call it B, using SOHCAHTOA, because there's our right angle. And then once we have those two numbers, we'll have the bottom side and the left side of this bigger right triangle, and then we'll be able to use Pythagorean theorem to find the hypotenuse. So that's our bigger plan. I'm going to start with my breakout triangle. I'll start by finding side A. In reference to our angle of 36 degrees, A is our adjacent side, and we know the hypotenuse is 20, so adjacent and hypotenuse, that's going to be cosine of 36 degrees is equal to A over 20. We'll multiply both sides by 20. That gives us A to be equal to 20 times cosine of 36 degrees. And we'll put that into our calculator. We'll get A to be equal to 16.18, because we're rounding to the nearest hundredth. And then I'm going to do the same kind of thing to find our side B. Now this time B is opposite our 36 degree angle. So we have opposite and hypotenuse. That's going to be sine of 36 degrees equals B over 20. And then I'm going to do all the same things. I'm going to multiply both sides by 20. That gives us B equals 20 times sine of 36 degrees. And into our calculator it goes, giving us B to be equal to 11.76. So I'm going to label those two numbers here on our original diagram. So now if we turn our attention to this bigger right triangle, I'm going to break it out. This side's 11.76. Our bottom, we're going to add that 16.18 to the 40. Get 56.18, and then all we need to do is Pythagorean theorem to find our x. Rounding to the nearest hundredth, we get x to be 57.40, and our unit is miles. The second part of this question is to find the bearing from port. So I'm going to still use this breakout diagram that I have, because this is our port location, and then this is our location at 3 o'clock. Now, if I have a due north line here, and we want to give the bearing in the same type of notation that they gave it to us in the original problem, which is, either north or south, and then a degree, and then east or west. So for us, for our bearing, what we're going to want is a due north line, and then figure out what this angle is, and that'll be our bearing to the west. Well, in order to find this angle, I'll call it alpha, it's going to be the complement to the angle inside our triangle, I'll call it theta, because we've got a right angle here with a due north line and a due west line. So I'm going to find that theta, and then its complement will be my bearing. From my angle theta, I have sides that are opposite and adjacent, so I'm going to use tangent to find that angle theta. Tangent of theta is going to be equal to our opposite side over our adjacent side. And then to find theta, we're doing inverse tangent of that fraction. And we get theta to be 11.76. 83 degrees. But remember, that's not the number that we want for our bearing, because that's our angle here, theta, that's inside the triangle. And what we need is that angle outside. We need the complement. That complement's going to be 78.18. So our bearing will be north 78.18 degrees to the west. In number 4, we have 2 lookout towers that are 50 kilometers apart. Tower A is due west of Tower B. So I can already start with my diagram a little bit. There's my A and my B. A roadway connects the 2 towers. A dinosaur is spotted from each of the towers. The bearing of the dinosaur from Tower A is north 43 degrees east. So they're giving me a bearing. I'm going to have to start with a due north line here from A. And then I'm going to rotate 43 degrees towards the east, which would be to the right. And then the bearing of the dinosaur, so I'm saying that the dinosaur is here. They give us a bearing again, right? North 58 degrees west, so here's a due north line. Then I'm going to rotate 58 degrees to the west. So that angle there is 58 degrees. We want to find the shortest distance from the dinosaur to the roadway that connects the 2 towers. So we're looking for this distance right here. And that is going to form a 90-degree angle there, that shortest distance. And we also know this total distance is 50. I'm going to start by finding these 2 angles inside these 2 triangles. That's a, straight west line on the bottom, and we have those 2 due north bearing lines. So we know that these are each 90 degrees. So we can find those inside angles by finding the complement. This one's going to be 47 degrees. And the other one's going to be 32 degrees. And we're looking for this shared side. I'll call it Y. Now, the big mistake I saw with this problem is that people said, oh, this side's going to be 25 and this side's going to be 25. And we don't know that to be true. Right? It didn't say it was in the middle. The bearings are different numbers. We can't make that assumption. So what we're going to do instead is we're going to let one of the bottoms be X. And then because they told us the total was 50, this other one is going to be 50 minus X. Our bigger plan now is I'm going to have 2 breakout triangles. This one here and this one here. And they both have that side Y. So I'm going to create an algebraic expression for each one of those breakout triangles and solve it for Y. Then we'll be able to set those 2 equal to each other and solve for X, which is the information we need to have to actually find our distance y. So let's do the two triangles. I'll do the yellow one first. So from our angle 47, y is opposite and our bottom side is adjacent. So that's going to be tangent. We'll have tangent of 47 degrees is equal to y over x. And I want to solve this for y. So I'll multiply both sides by x. And that's going to give us y to be equal to tangent x times tangent of 47 degrees. Now I'm going to do the same thing for the green triangle. From our angle of 32, y is opposite. That 50 minus x is adjacent. So we're going to use tangent again. Tangent of 32 degrees is equal to y over 50 minus x. And I'm going to solve this for y. We'll multiply both sides by 50 minus x. And that gives us y to be equal to 50 minus x times tangent of 32. Since both of these are equal to y, our transitive property of equality says that we can set those two equal to each other. So we're going to do that. So x times tangent of 47 degrees will be equal to 50 minus x times tangent of 32 degrees. And now we need to solve for x. So we have to think back to algebra. All right, the x I'm trying to solve for shows up in more than one place. We use the same technique when we learned how to solve by factoring in intermediate algebra. We use the same technique in college algebra when we solve logarithmic equations. We are going to distribute our tangent on the right side. So I still have x showing up multiple places, but it's not trapped inside the parentheses anymore. Next, we want to get all the terms containing x on one side of the equation and all the terms that don't have an x on the other side. So we're going to add this over. Now, this is not a like term with this x tangent of 47 degrees that we have here on the left, so we're just going to have to write them next to each other. We now have a common factor of x on the left side that we can factor out. And now when we factor that x out, the x only appears one time. And then to solve for x, we just need to divide by all that stuff in the brackets. We get x to be 50 tangent of 32 degrees divided by tangent of 47 degrees plus tangent of 32 degrees. And into our calculator that goes. We get x to be 18.41. And what that gives us is the bottom of that yellow triangle. So I'm going to draw a breakout of it. And now that we have the bottom of that triangle, we can use SOHCAHTOA to find y, which is that right side of the triangle, which is our distance from the dinosaur to the road. From our angle of 47, y is opposite and 18.41 is adjacent. So we'll use tangent again. Tangent of 47 degrees is going to be equal to y over 18.41. Solving for y, we will multiply both sides by that 18.41. We get y to be equal to 18.41 times tangent of 47 degrees. And we'll put that into our calculator. We get y to be equal to 19.74, and our unit is kilometers.